Hello, everyone. Thank you for watching. We are a junior design team, and for our project, we decided to build a contactless scanner. Some key features that are unique to our build are that it uses an RFID reader to wake up the machine and grab the user's information. And then this information, along with the temperature read, will be stored on an SD card. Some difficulties we had was having a remote project partner. And so to resolve this issue, we met multiple times a week. And because of this, I believe that we overcame this issue as we had almost no problems during this term. And then looking towards the future for this project, we were thinking of making it handheld or mobile by having its own battery so it does not need to be plugged into the wall. And now for the requirements.
So for the requirements, there are 6 of them. First, the temperature sensor needs to be accurate within plus or minus 1 degree Fahrenheit of a store-bought thermometer. The system should alert the user if they have a fever with both audio and visual cues. There should be no contact involved, and the device should be usable from a distance greater than 1 centimeter. It needs to log data for at least 24 hours. It should be intuitive to use. And finally, it should accurately log the real world date and time with temperature data.
Here we have our block body diagram that incorporates all of our components used in this project. Each block has both inputs and outputs that relate to specific interfaces in the design. Each block is color-coded to the person responsible for it and will be further explained in the following slides.
So the first block is the infrared temperature sensor. It communicates with the Arduino using the SDA and SCL pins and operates at a voltage of 3.3 volts. And because of its small field of view, it has a range much further than 1 centimeter. The next block is the RFID module. It communicates with the Arduino using the SPI bus and also operates at 3.3 volts. The module is able to scan a card from over an inch away, which is more than the required 1 centimeter.
The next block is the real-time clock. This also uses the SDA and SCL pins on both the real-time clock and the Arduino, and it provides an accurate time of consistently within 1 second, and it has its own battery, so even if the whole system is unplugged, the time does not need to be reset. It will continue to accurately provide the correct time.
The OLED display block receives data from the SDA and SCL pins from the Arduino. It operates on 3.3 or 5 volts. And once the data is processed from the Arduino, it will output the name of the person, temperature taken, and the data of the temperature that was recorded. Here we have the SD card module. The micro SD board will store the data that has been shown on the OLED display. It communicates using SPI and operates on 3.3 volts. It will also store the same data that was displayed on the OLED display.
Now here are a couple pictures of our completed system. On the right, you can see all the components tied together. Our PCB board is that purple board in the middle, kind of acting as a shield on top of the Arduino below. And on the left, you can see the entire project finished. The scan here is where the RFID scanner is. There's the LCD screen, and the temperature is taken at the end of the green cylinder. So we're really happy with how our project turned out. But some ideas that we had to improve it or take it another step further was improving an interface to access the log information. Even though the SD card is solid and it's fail-proof, creating this would make it more user-friendly. And then installing a battery and a backup battery would allow this to, again, be fail-proof, and then it would allow it to be mobile, maybe transitioning to more of a handheld device, which would be really interesting to see in the future. Thank you so much for watching, and have a great day.